Hi, everyone. Thank you for joining us this afternoon. Today, we'll be going over the Clearwater project construction update. We're going to go over, construction updates, right? The title says it. Little cool fun facts about how the tunnel boring machine works. We'll get to see videos of it in live action. So that's going to be very fun. But before we get started, just a few things. If you have any questions, you can use the Q&A feature. It's located at the bottom of your screen. You'll notice it says Q&A. Or if you want to ask your question live, you can do so by using the raise hand feature. That's also located at the bottom of your screen. Unless you're using a mobile phone or tablet, it'll be on the top right. So yeah, questions, use Q&A feature or use the raise hand feature, and we'll answer the questions at the end of the presentation. And to kick us off, we're going to have Glenn Acosta, senior engineer, who's going to introduce the project a bit if we haven't heard of it already, and then we'll hear from our project engineer expert, Russ Vicaria. So Glenn, take it away.
Well, good evening, everybody. We are super delighted to give you this update on the tunnel construction for the Clearwater project. And before I hand it off to Russ Vicaria, who's actually overseeing the construction, I thought I would do a brief recap as to who we are as an agency and why we're doing the project. All right, let's see who goes here. So we manage the sewage for over half the population in Los Angeles County, 5.6 million people. Our service area goes from the South Bay all the way to the Antelope Valley. And we manage the sewage by directing the flow of sewage from homes and businesses through our sewer pipes into our 11 wastewater treatment plants shown here in the green pins. Our largest wastewater treatment plant is located in Carson. It is called the Joint Water Pollution Control Plant. It is the largest wastewater treatment plant in our system. It is also the hub of the main sewer system that serves the southern half of the county. So 73 cities, 5 million people depend on this plant to operate 24/7 without failure. And essentially, sewage flows into the plant, and in less than half a day, we turn that into clean water, and that clean water goes out to the ocean through 2 tunnels shown here in the orange lines that were built 60 and 80 years ago. And these tunnels were not built to current seismic standards. So in addition to their age, their seismic issue is also something of concern. So the Clearwater project is about addressing this aging infrastructure by building a brand new tunnel. And here to give us the latest on the tunnel construction is my colleague, Russ Vicaria.
Thank you, Glenn. So as Glenn mentioned, as part of this project, we're going to be building a new tunnel. So right now, the tunnel starting point is the wastewater treatment plant that you see in yellow above where it says JWPCP. And the 2 tunnels that are currently existing are shown in purple going down to Royal Palms Beach. And the new tunnel is shown with this green line. It's has quite a few more curves than the existing ones. And we're staying under public roadways per public request. And that's why it has so many curves. The construction cost is $630 million. And we'll talk more about it coming up. So where we left off last time, if some of you attended our previous sessions, we had a tunnel launch ceremony some time back where we introduced the tunnel machine. And here you see the side of the tunnel machine sitting on top. The tunnel machine is named Rachel, after Rachel Carson, who's the author of Silent Spring. She was an environmental pioneer back in the 1960s. And here's some of the artwork from local students that's put on the side of the machine, and the logos of some of the firms involved in the project. So this is how the tunnel site looked like when the tunnel machine was sitting on top, last year. So here's the tunnel shaft where the machine was launched from. On the left side, you see the front of the tunnel machine. And on the right side, you see all the trailing gear that's pulled along behind it. and the direction of tunneling is shown with this blue arrow. So lowering and assembling this tunnel machine was really a challenging task. And the reason is this. So here we have SoFi Stadium, 3 of them laid side to side. The tunnel machine is 800 feet long. So if it spans basically almost 3 of these football fields. So this long a machine had to be launched from a tunnel shaft this size. So it had to be put down in pieces, which made it really challenging. So here is the first piece of the tunnel machine being lowered into the shaft. And you can see the crane lifting it. It's a very heavy piece. It's the guts of the tunnel machine. And you see it being swung over and then being lowered down into the shaft. And here it is sitting at the bottom of the shaft. And now the next piece is being lifted. And this is the piece that rotates and actually digs the ground as we move forward. So you see this piece also being swung over. And then it will similarly be lowered down into the shaft. So the picture on the left side shows the 2 pieces you just saw at the bottom of the shaft, and we're looking down it. And in front of the machine is a 30-foot long starter tunnel that was pre-excavated to help launch the machine. And on the right side, you see this picture where the front of the machine has been pushed into the starter tunnel, and then a subsequent piece is being lowered. And this is done progressively to launch the machine. So this is how the machine looked when it was assembled a couple of years ago in the factory in Germany where it was produced. So you see the front of the machine on the left side and all this trailing gear being pulled along behind it. So this trailing gear is like a moving underground city, and it's there to provide life support and other features to keep the tunneling going on. And it includes ventilation, power cables, transformers, pumps and piping, sensors, safety equipment, and much more. Everything needed to support this tunnel machine as it goes 7 miles. Here's a picture of the trailing gear sitting on the surface, and it runs on rails. And you can see this gentleman standing to the side, so you can see kind of the scale of the trailing gear. And for example, on top, you see the ventilation line hooked to the top of the trailing gear. So here's one of the picture on the left side shows one of the pieces of the trailing gear being lowered down. And then on the right side, as it's sitting at the bottom. And you see in front of it, the excavated tunnel. And this video shows that piece of trailing gear being pushed into the tunnel. And as it's pushed into the tunnel, it's hooked up to the pieces that are already inside the tunnel digging forward. So the challenge is this: you've got to assemble this machine piece by piece, all 800 feet of it, while you're tunneling forward and you're feeding this machine from the surface. So all these cables, fluid lines, power lines are feeding the machine. And again, you have a 55-foot diameter shaft and you're launching an 800-foot long machine using that. So here's an overall view of the alignment looking south. The tunnel shaft where we started mining is at the bottom. The green arrows show the tunnel alignment. And the current location of the tunnel machine is shown in red. So we've already gone south, down across the Harbor Freeway and through Harbor Park Golf Course. So this is a drone view, and it shows the tunneling that's been completed to date. So the tunnel machine came out, went diagonally across the shaft, went down south, and then past PCH, and made an 800-foot radius turn under the freeway, and then into Harbor Park Golf Course. And so we've been under Harbor Park Golf Course for the past several weeks. And again, there's a lot of golfers playing golf and they have no idea what's underneath them. And the tunnel machine currently is in approximately this location. And of course, we'll be continuing to mine forward. So let's talk a little bit about the tunneling process itself. Now, those of you who attended past presentations, you may have seen this. So the way the tunnel machine works the head of the tunnel machine rotates and the jacks push off the ring that was previously erected, which is made up of 6 concrete segments. Then the jacks retract and a new ring is built. And then the tunnel machine pushes off and moves forward. And that's done 5 feet at a time. And so that's how the tunneling process works. So here's the same process, the erection of the segments within the tunnel machine, but actually how it's occurring in the tunnel machine. So you see the jacks retracting and a new segment being lifted up by the tunnel machine. And this is all going on inside the tunnel machine. So each one of these rings has 6 segments that are erected. And then once that's done, again, these jacks push off the last erected ring and move the tunnel machine forward. And once a ring is set in place, the tunnel miner is bolted in place, and then we move forward. So one of the questions I'm asked very often is, how does this tunnel machine turn? Because we've got 30+ curves of various different diameters. So on the left side, you see the tunnel machine, and the tunnel shield, which does the digging, is made up of these 3 sections. And on the left side, you see these green cutting wheels. So they turn and they dig the ground. And then in the blue rectangles are articulation cylinders. So the tunnel machine operator can use these articulation cylinders to turn the head of the machine and to make whatever diameter curve is required. And another question that's often asked is, we have all these different diameter curves, so we must be making specific segments to each curve. And actually we do not. We have one universal ring. So each one of these is a ring made up of 6 segments, but it's a tapered ring. So the distance shown in red is different than the distance shown in green. So you can rotate that ring, and you can, depending on the degree of rotation, you can navigate a curve. So again, we have no specific special rings made for this job. They're all universal, and we just rotate them to make the curves. So a lot of the tunnel miners, all the segments, any piping and materials that are brought to the tunnel machine are brought using these rubber-tired vehicles. And you can see on the left side, this is one of the rubber-tired vehicles sitting on the surface. And this is the same rubber-tired vehicle in the tunnel. And you can see it's carrying some segments as it moves in. So this is a picture taken inside the tunnel. And you can see this is a trailing gear. Again, it's designed so that the rubber-tired vehicles can run within the trailing gear. And you can see that it's riding on these rails as it moves forward. And one of the challenges for the tunnel miners is, as the tunneling moves forward, they've got to extend all these utilities, including the ventilation at the top, the slurry lines to the left, fluid lines to the right, the power cables, in order to keep supplying the tunnel machine. So this video is taken while riding on one of the rubber-tired vehicles. Right now, it's within the trailing gear of the tunnel machine. And you'll see as it moves away, this is sped up, of course. And here it's navigating a curve, and it's heading back towards the shaft. And this is the same vehicle appearing at the shaft to offload material or to load material to take it back to the tunnel machine. So one of the things that needs to happen is the cutting tools for this tunnel machine have to be inspected and sometimes replaced as it's navigating along its way. So as I mentioned, the green arrows show the alignment of the tunnel machine. And we have 3 planned maintenance stops that are shown with the gray rectangles. We already completed the first maintenance stop, and then we'll be completing another one coming up. So the maintenance stop, all it is we pump grout into the ground to create a watertight block. Because again, we're under the water table. So we created these blocks, and then the tunnel machine drives into the block. It can depressurize. You don't have to worry about water intrusion or soil intrusion. And then the tunnel miners can inspect and replace cutting tools as needed. They can also do this outside the maintenance stops, but it's a much more involved procedure, which involves like a deep sea diving type operation with working in compressed air. So the tunnel miners who build the job work 24 hours a day, usually 5 days a week. It's 3 8-hour shifts. And they also sometimes mine on Saturday. There's certain locations where they're also mined 7 days a week. So before each shift, the tunnel miners get together, there's a safety meeting, and then they go down into the shaft and to the tunnel machine. So the left side, you see the tunnel miners, they have this brass board where they basically have each one of their names, and they basically mark that they're inside the tunnel. So if there's any kind of safety issue, anything that happens, you know who's in the tunnel and who needs to be evacuated if needed. And then this is the swing shift. So they go in during the day on the left side, and then they come out when it's already dark, and then they're brassing out. This is one of the TBM operators, and this is inside the tunnel machine. So this is a very mechanized, automated tunnel machine, which you also need the tunnel miners there to assist in the operation. So this is one of the district's inspectors. Here's that brass board I was talking about, and he's going to explain a little bit about the safety equipment that everybody has to wear to go down in the tunnel and the procedure to go down.
Hello, we're here at the LA Outfall Tunnel Project, getting ready to go down into the shaft to do some inspection. Prior to going down, we need to make sure that we check ourselves in on the brass board. We take our tag, we take it from the out, we put it on the inside. And you also make sure that we have our proper PPE, which consists of our safety vest, our hard hat, our H2S monitor, our self-rescuer, and also rubber boots are needed. And then we are able to go.
So John, our inspector, is getting into the elevator that will take him down into the shaft, just like the miners do. And this is a video taken from the bottom of the shaft looking up. So anybody coming down comes down in this elevator, and then you'll see a little shot from down below. We're here in the tunnel. You can see the ventilation lines up above me that feed the miners that are there, slurry lines and other fluid lines that feed the tunnel machine and keep the tunneling operation going on. And you see the tunnel segments here that are erected by the tunnel machine as it's moving along. So the other thing that's very important on this job is monitoring the tunnel machine, because this is a very complex machine and it throws off several hundred data points, every few seconds. And so you have the tunnel machine on the left side. It's connected by a fiber optic line to a computer server in the district's trailer on site. And then that information is backed up to the cloud. And we get this information in real time to our computers and our cell phones, so we can see exactly what's going on. And the contractor sees this, and the district staff and inspectors also see it. So this is one of the screens that's in this software, this TPC software that manages the data from the tunnel machine. You can see it, various things. On the left side, you can see if the cutter head is turning clockwise or counterclockwise, how fast the machine is advancing, how quickly the cutter head is turning, how much thrust force or torque is being applied. And up here on the top side, you can see, is the tunnel machine currently digging? Is it erecting a ring, or is there waiting time? And there's lots of other data in here that everybody monitors to make sure the process is working as intended. The other thing this software does is you can get daily tunnel reports. So across the top is the time of day, and minute by minute, it logs what's going on. So the green bars show whenever the tunnel machine is actually digging. The yellow bars show when the tunnel machine is erecting a ring. And then the various other bars below show any kind of waiting time that's categorized. And this is stored so it can be brought up in the future if you need to look at historical information, or you're just trying to see how the tunnel machine is operating. This is another view from the software. This is like a GIS view. So you see Pacific Coast Highway here, and then the Harbor Freeway, and this was taken some time back. So you can see the exact location of the tunnel machine here in yellow and red. And all these white circles are ground monitoring instrumentation that you can click on and see the status of each one in real time as you're going along. You can do this on your cell phone, on the computer, or tablet. So one of the things that's important is communication. And the tunnel machine may be a mile, 2 miles, 5 miles down the line, but there is Wi-Fi in the tunnel. So you can communicate with the inspectors, and the contractor can communicate with their people at the front of the tunnel machine. So it could be the middle of the night. Sometimes you're mining, you may be thinking about what's going on. Sometimes there's critical operations, like when you're going under the freeway, and you can text the inspector and ask a question. And then the inspector in the tunnel machine, they've got Wi-Fi on their phone. They can send a picture, video, or communicate back. And again, the contractor can do this, and district personnel can also do this. The other thing this software does is it analyzes the tunneling process. So this pie chart shows what percentage of the time the tunnel machine is advancing, meaning digging, what percentage of the time it's building a ring, and then waiting times. And this information can be sliced and diced. You can print this for a day, for a week, for a month. You can see how the trends are going. So the contractor uses this, the district also uses it to monitor the tunneling process. It also will give you various histograms and charts showing average daily production and a whole host of other data points. So the tunnel segments that are erected by the tunnel machine are built offsite in a production site up in Palmdale. And it's a very automated production site. On the left side, you see one of the segment molds. And on the right side, you see the robots. So it's a combination line that's operated by people and robots. And the concrete's poured in here in one of the molds, and then the segment is cast. So this video shows what the workers up at that plant do. So here's a mold, and they're getting it ready. They're putting the gasket in place, and they're getting ready. Here, the concrete is deposited into the mold. And then they make sure that everything is smooth. The concrete segment is finished properly once it's cast. And of course, they got to clean the mold, and then the completed segment is lifted off via conveyor and stored outside and then trucked to the site. And here you see some of the gaskets on the segment, because these segments have to be watertight because they're well under groundwater. And again, this is one of the these are a couple of pictures from this facility in Palmdale where all these segments are stacked up, ready to go. The other thing that's important to do is monitor the ground to make sure the tunnel machine is operating properly and make any kind of adjustments that are needed. So this ground monitoring is also done remotely and wirelessly. So these pictures along the side, on the bottom left-hand corner, you see an underground point that monitors ground movement underground. You see a structure point that monitors any kind of structure nearby, or a ground monitoring point on the right side. So all these points give off wireless data, and these are read wirelessly by these total stations that then transmit the data to us, and we can view it on cell phones or computers, and the contractor can also, to make sure that everything is going properly. So this is one of our inspectors who's going to explain some of the ground monitoring that we did at Harbor Park Golf Course.
Hi, I'm Greg Degner, one of the inspectors here on our tunneling Clearwater project that we have going on. Right now, we're currently at the LA Harbor Golf Course, and I'm here to explain a little bit about the instrumentation that we have installed here at the golf course to make sure that we're not disturbing any of the ground that we're tunneling under here today. So to my right here is our total station. The total station is basically the device that is recording the ground level and the different elevations that we have throughout the golf course. What it's doing is it's shooting a laser to different prisms that we have set up. There's one here on the asphalt. It is low profile, so the golf carts and golfers can avoid hitting it, so we can keep our data nice. The prism in the front there reflects back to the total station and records that elevation that we're at. And then we can monitor throughout the day. It can go every minute, the readings, and it'll let us know if that ground is moving. Part of the components here, we have a solar panel and also backup batteries that will keep this machine running. So the solar panel is the black part in the back. The red case down here, backup batteries. And then, like I said, at the top is your total station. And this piece right here has been added for protection from golf balls that might be hit. Right now we are currently between two fairways. So one of the things that we do have to be careful is, one, that we're not interfering with the golfers as they're here today, and two, to make sure that our equipment is still sound.
So all this information is transmitted and we can view it on screens like this. So here you see a road and all the white circles are various instrumentation that you can click on and you can see the data in real time. So the project timeline, we started mining a few months ago. The tunnel mining is scheduled to go until late 2024 and it'll end at Royal Palms Beach. And then at that point, we have another 2.5 years of work to do down near the beach, which is the subject of another presentation. So that's the overall time frame for the job. And we can take any questions you may have.
All right, thank you, Russ. And we have a few questions lined up already. So let's see here. I'm going to stop your screen share. And then we'll get right on to the questions. Oh, actually, before I go into the questions, if we can, I have a short poll, like short 3-question poll. And if you could please take the time to answer, it should be very brief. Your feedback is super important to us and we're always looking for ways to improve our tours and our presentations so that you get a better experience. So if you could please fill that out and then I will get into the questions. Let's see. All right. So the first question, Glenn, if you could answer this one. Why is water going into the ocean? Can it be used for irrigation?
That's a great question. So as I mentioned earlier, we operate 11 wastewater treatment plants. So in 10 of those plants, we actually recycle the treated or clean water from those facilities in various ways, like recharging the groundwater aquifers. But the water from the joint plant is actually too salty to reuse. And so that's been the case for many years, which is why we discharge it to the ocean. However, recently, in the last few years, we have partnered with the Metropolitan Water District of Southern California to take that clean water, purify it, and make it into drinking water so that in turn can be distributed in the region to replenish the aquifers. So we're working on creating a new local source of water that's drought proof. And so right now we're in the environmental planning stages. And so we're planning out what the full scale facility would look like, where the pipes will go, and we're going to be taking public comments on that project. But over the last couple of years, we actually have been operating a demonstration facility at the Carson plant to test out the technology. So we divert about 500,000 gallons per day from the plant and send it through this demonstration facility to purify it. And so we can test it and hopefully use that data for a full-scale facility.
Awesome. And if you'd like to learn more about the Pure Water Southern California program, you can visit their website, which I will link in the chat. All right, so next question we have from Patricia Baker. This one's for you, Russ. How do you ensure that the tunnel will be earthquake safe?
It's a good question. So structural engineers looked at this during the design phase. And one of the reasons we're building this new tunnel is because the 2 existing ones are not made to seismic standard and they could potentially be compromised if there was an earthquake. This new one is to seismic standard. And once the tunneling is done, we'll insert steel liners at the earthquake faults to make sure that it's earthquake resistant. So that has been factored into this project.
Okay, great. And the next question is, how far down is the tunnel?
So right now, we're about 6,700 feet in, so, about 1.25 miles out of the 7 miles.
And next question, could you please tell us the average distance that is drilled each day?
Good question. So on many days, this tunnel machine will go 80, 90 feet. The best day has been a little over 100 feet, but the average winds up so far of late being, more like 55 feet, 60 feet, because one thing that happens is there's sometimes maintenance issues come up. You've got to stop to check the machine. So that brings the average down. So our overall estimate is about 50 to 55 feet a day.
Thank you. The next question is, where does the dirt go while you're excavating?
So the dirt goes to one of these plants up in Irwindale, and they reuse that dirt for other purposes up there.
Then we have another question from Tim. He says, as I travel on the Harbor Freeway, I've noticed considerable storage of tunnel cuttings on site. Do we usually recycle this material?
So it is taken to a facility that does reuse the material, and they can use it for whatever they want. So it's not being sent to a landfill or anything like that. It is being sent to a facility that does reuse.
Okay, great. And next question from Mary Ellen Barnes. Does the tunnel emerge at the ocean above or below the sea level?
So there's a shaft that will be dug at the receiving site, and the tunnel machine will come in below and will be lifted up, and then that will be tied in to the existing outfalls that we have that go from the beach out under the ocean. And we'll do a future presentation on that because that's a whole big project, sub-project in itself.
We'll definitely have a presentation on that.
For sure.
That one's super interesting. Okay, and please please fill out the poll if you haven't done so already. Okay, so next question. What happens to the machine after construction?
Okay, that's a very important question too. So this machine's 800 feet long, and it's difficult to completely reuse these machines. It's possible that if there's a similar job, similar conditions, same diameter, you might be able to refurbish and reuse it. This machine is going to be used over a 7-mile stretch. So most likely a lot of the parts will be recycled. They'll be pulled apart and will be either refurbished or used on other machines in the future. But all of it will be pulled out at the end.
And that's perfect because there was a follow-up question if it could be used.
But there are some projects done by some public agencies that allow refurbished machines. We didn't allow that here because we've got a long job from one shaft going 7 miles. But a lot of times, if you've got shorter jobs, an agency may say you can use a refurbished machine.
Great. And there is a question if this presentation will be viewable later. Yes, this presentation is currently being recorded, and so it will be posted on YouTube by latest tomorrow. I will post the link for our YouTube channel in the chat. It's youtube.com/Los Angeles County Sanitation Districts, but I'll put it in the chat so you can subscribe and then you'll get notified when we post a video. All right, so the other questions are, what will become of the old tunnels?
Another really good question. So and we'll explain this in a future presentation, but once this new tunnel is done, all the flow from the plant will be diverted through this new tunnel, and the 2 existing ones will be dried up, and they will be inspected by district staff, and some decision will have to be made regarding if they need refurbishing. But the final objective of this job is that all 3 tunnels then would be tied into the manifold structure at the beach and would be usable, and that way we have some redundancy also.
Okay, great. Now, the next question, and we're just filled with good questions. So next question is, how exactly do they get that dirt that they excavate? How exactly do they get that out for transportation?
So it comes off a conveyor, it's loaded onto trucks, and then and the trucks are covered and then it's hauled off site.
All right, and how many gallons per day are currently going out into the ocean?
From this plant, it's roughly about 200 million gallons a day, 250 million gallons a day, but that varies a lot. And so if it rains, that could go up, and it's even peaked at over 600 million gallons. So there's a lot of rainwater infiltration into the system. So it can vary a lot during the rainy seasons.
Great. Next question. Can you make tunnels underwater?
You can. For example, if you go up to the Bay Area BART system, they tunneled under the bay. The Channel Tunnel between England and France is also tunneled under the English Channel. So that can be done.
All right, great. And by the way, I'm also going to put a link in the chat to our Clearwater project website. So if you'd like to receive more updates along the way, our newsletter, you can join by visiting our website. Okay, so next question is, you told us about, how we're sure that it'll be earthquake proof, but now the next question is, how are you certain that this tunnel boring machine will work?
Well, a lot of time and effort went into planning this project. It was over 10 years in the design phase. And we have tunnel designers who are experts in this field, who've done lots of tunnel jobs elsewhere, who designed this job. The contractors were pre-qualified prior to bid, and we selected one of those pre-qualified bidders. And so we have a lot of people on this project. We've got tunnel consultants also working for the district who've monitored similar projects. So we have a lot of tunnel expertise, and a lot of planning's gone into it. And so you do whatever you can to prepare and be ready to manage a job like this. And again, we've already mined about a 1.25 miles.
Okay, now next question. There was talk of other entrance tunnels along the route. Will there only be the one entrance tunnel?
Correct. So the tunnel machine started at that shaft site in Carson, and there will be no intermediate connections to that. It will just emerge from that shaft at the beach 7 miles down the line.
All right, and have you ever had a big accident while excavating with the tunnel boring machine?
Not on this job, and we try to do our best to look ahead and to try to prevent those things from happening.
Awesome. Now, next question for Glenn. Does the additional salt that we discharge out into the ocean, does that have a negative effect on fish life?
No, because the salt level is far below what you would see from ocean water. And the water is actually very clean that goes out to the ocean. And if you were to do a scuba diving trip down there to our outfalls, you would see that there's a lot of marine life from where the water comes out at the end of the outfalls. Additionally, we have an ocean monitoring group for our agency, and they actually take samples near the outfalls. They take samples of the ocean bottom, of the fish. And so all this data verifies that the water is actually good for the environment, the marine environment. And we share this data with other agencies and the state.
Okay, great. Thank you. And before I ask the next question, please, if you have any questions, please put them in the Q&A, or you can use the raise hand feature and you can ask your question live. And if you remember, after this presentation, you can send us an email. I will also put our email on the chat so you can contact us after, but feel free to send us anything you think of in Q&A. All right, so we have a few questions here left. So next, have there been any geological surprises when digging?
Nothing of significance. The ground always varies to some extent as you're going, from Carson to White's Point, and we're going through soft ground right now, and then it'll become rock. So nothing major, but it is always changing to some extent.
Okay, great. And I think I misspoke. I think that's actually, we have one more question. Do you have any tours of the joint plant available? And we just had our tour, right, of our joint plant about a month ago. And so I will post on the link. I'm gonna be posting on chat, like just a lot. So I'm gonna post on the chat a link to our tours page where you can see our upcoming schedule. I know we just had one at the joint plant. We may be having another one earlier next year or so. But if you'd like to request for a tour, any private tour for like a group, a classroom, please feel free to send us an email at info@lacsd.org and we'd be more than happy to get you a tour of the joint plant. And yeah, does anyone have any other questions? I think that is it. Glenn, Russ, do you have any closing remarks?
No, we'll be doing updates, down the line, and especially as we discussed, when we get closer to the beach, we'll be doing more updates on that. And as Genesis said, feel free, if you have any other questions, submit them on the website. We'd be happy to answer them.
Let me just add that, we've been out there in the community for several years now. And so if your group is interested in a presentation, either similar to this or with other features, other topics related to the project, we're more than happy to come out and give you that presentation. We also have some pretty cool, exciting school programs. We just added boat trips for the schools where the kids can actually go out and boat. They'll take marine life from the LA Harbor. They get to be a hands-on experience. We have field trips to our water purification facility that I mentioned earlier in Carson, as well as presentations to classes on environmental stewardship and other things. So there are a lot of opportunities for you and your kids to learn. So just contact us and we'll be happy to do it.
Perfect. And I just put our link in the chat again to the Clearwater Project website where you can find out more about all of that information, whether it's for schools, whether it's for tours for your own organization or for our own for our own newsletter. So with that, we will end tonight's presentation. And if you have any other questions, please feel free to send us an email. But thank you so much for joining us.
Thank you.
Good night, everybody.
Thank you. Good night.
Thank you.